So, we did that investigation and we looked at some of these things, but I want to formalize this into some notes a little bit. First of all, a translation is a shift. So basically it's taking the same shape of the function, but it's sliding it up, down, left, or right. A dilation changes the size. So in this case, usually we solve for y, so most of the time you're going to see this as y equals f of x minus h plus k. So if I have something, it means that it's shifting, it's translating. Let me just use the correct word. So translated, which means shifted, h units left or right, and k units up or down. Which means if I have something like y equals x plus 2, f of x plus 2, sorry, minus 5, this is translated left 2 units and down 5 units. Now, people get a little confused because they say, wait a minute, plus 2 is left, so I'm kind of doing a sign change here, because left I think of as negative 2. But then why am I not doing a sign change on my y? It's because there was already a sign change there. This would have been like y plus 5 equals f of x plus 2. In this case, reflection, it's going to reflect across the x or y axis. If I'm changing the sign on my x values, think about if x was positive 5, now it's negative 5. If x was negative 1, now it's positive 1. So this is reflected across the y-axis. And here, again, normally we have it solved for y. So I would divide both sides by negative 1 or multiply both sides by negative 1 in this case to solve for y. And then the right side of my equation would look like this. So this is a sign change on x. This is a sign change on y. So if it's a sign change on y, it means it's reflected across the x-axis. Now, here's something that just seems weird. And that is when you have a dilation. Again, normally we solve for b. So y equals b times f of x. And this part sort of makes sense intuitively if you think about it. If the absolute value of b, so the sign change would tell us it's a reflection. We just care about the absolute value. If b is negative 2 versus positive 2, the dilation is going to be the same. If 0 is less than the absolute value of b, which is less than 1, it means this is a vertical shrink. Just like this was a sign change on y, this affects the y, the size of the y dilation. If the absolute value of b is greater than 1, this is a vertical stretch. Now, the reason this gets weird is because you want to kind of think of the same thing here. But the way this works, if 0 is less than the absolute value of a, which is less than 1, that would be like I'm dividing by 4. This actually becomes a horizontal stretch. And if the absolute value of a is greater than 1, this is a horizontal shrink. And the reason that looks weird is this. Think about it. If this is something that's linear, so let's say y, or let's even do an absolute value. Y equals the absolute value of x. Well, there's really no difference between y equals 1/2 times the absolute value of x. And 1/2 would make this a vertical shrink. And if it's a vertical shrink, it takes my basic absolute value thing and it does this kind of a thing to it. It's no different than if, in this case, y equals the absolute value of 1/2 x. Now, in quadratic, it doesn't work quite the same, but these are sort of linear in that each one of these rays is kind of half of a line, if I want to think of that. Not good math phrasing, but, well, now, this is like x divided by 2. 1/2 x is like x over 2. Oh, vertically this thing is shrinking, but horizontally it's stretching out. So a vertical shrink is like a horizontal stretch. Now again, in quadratic it gets to be a little bit more complex, but in this it's a little bit easier to see why. So in this case, this is like y equals negative 2x plus 6, which means this is, with the negative, it's reflected across, and it's a negative in front of the x. The y-axis it is a vertical stretch with a factor of 2. And it is translated up 6 units. The parent function is linear, and y equals x would be the parent function. Here, the parent function is quadratic, and the parent function of that is y equals x squared. The only thing here is this is translated up 10 units. Here, because x is being divided by 4, first of all, it's an absolute value. The parent function is y equals the absolute value of x. And because it's being divided by 4, the x's, this is a horizontal stretch with a factor of 4. Just going to start saying that to make it easier.